Datera delivers high-performance data orchestration and advanced automation to large enterprises and cloud service providers, reducing storage management and infrastructure costs by as much as 70%.
Data centers today being extended from on-premise to the public clouds. And that brings in applications running in everywhere. On one hand, you have applications like Oracle, traditional monolith. And on the other hand, you have applications like Cassandra, MySQL, Kafka, which are microservices based. Since applications across the spectrum need resources, there never been a requirement greater than today to have storage resources built such a way that they can cater to both the types of application in a very seamless fashion. Today, we're going to talk about how these applications are changing the landscape of technology and why infrastructure management and operational simplicity is key and more important today to cater to needs of these applications. Applications like Oracle, MySQL, before they can be introduced into the data center, they need to make sure that resource requirements are met. So if an application wants a resource like LUN1, LUN2 for 100 GB, 2 terabyte, they need to make sure that there is a 100 GB and 2 terabyte LUN exists in the resources pool which they can map. If these requirements are not met, applications simply cannot run. Or be it the applications like MySQL, which are microservices based and needing resources for individual pieces, but we still have to make sure that the storage pieces or any of the resources are already there in the system before they can actually start using them. Now, this poses a very generic challenge for all these applications that resources need to be well configured and well defined before actually you can start using them. With this kind of traditional environment, there is always a greater challenge for application developers because now they need to be aware of the system resources, what the system has, what the data center has, before they can design their applications. And that puts a greater challenge because they are not thinking about their applications anymore. They're also thinking about the environment where this application is going to run in. And that puts a greater risk because your application may be underperforming, may be underachieving what it can do had it got these tasks being taken by somebody else. These typical environments, for them to grow, we need to keep these two worlds isolated. Applications need to float in a separate space compared to where the resources are coming from. As long as these two worlds are isolated, applications can scale up and scale down and put in a dynamic requirement for resources without worrying about where the resources are coming from. At the same time, the resources can be delivered by vendors without worrying about how the application is going to consume them. So it means it needs a framework which can actually let these two worlds grow independent of each other, where application vendors and resource pools are completely separated but managed by a single entity to make sure that resources are effectively used. The applications are able to grow efficiently and resources are not getting wasted because there are applications which have pre-provision or thick provision them. So Kubernetes is the framework that keeps this thing simple. So Kubernetes I will always use as something whenever you want your life simple and you want to have a requirement like this is what will achieve you do that. So what Kubernetes does, it basically fulfills the promise. It basically lets you define your requirement in the form of PVCs. It has constructs for everything, CPU, memory, storage. For storage, typically they use something as a persistent volume claims. And for letting the vendor define their resources, they have something known as PVs, which is the persistent volume. So whenever an application wants a resource, they convey their requirement in the form of PVCs. And these PVCs are matched against any of these PVs to achieve the purpose what this application has been designed for. With letting you abstract out your requirements in the form of PVCs and application vendors not worrying about how the resources are being designed or created or supplied, one can convey the requirement in the form of most simplistic fashions. Just like that, you can say, okay, hey, my application needs something super performant. Or I can say something here that I want highly secured. It's not for the application vendor to worry about that how these resource requirements are going to be met with this resource pool here. They're going to be resources which may be defined as high performant, or highly secured. It's up to the framework designed with Kubernetes to match your requirement with certain intentions to be met with the resources which actually fulfills the personality that you have asked for. So no longer the users need to convey the requirement saying, I want 100 GB with these many IOPS and this kind of protection schedule. All they can just come and say, I want a PVC which is super performant because I've labelized my requirement in more humane form. And it is left to the world of vendor to define a resource which actually can fulfill the need what this guy has been asking. So if I want something as even more abstracted, saying, okay, I want something as gold, I don't care how this gold come from here. As long as a vendor says, okay, this resource has been tagged as gold, system gonna pick up that gold resource, match it with the requirement here, and make it available to the applications. So application developers' job has become super simple. It's extremely easy to scale the applications up now without worrying about how the resource is going to be supplied. And that's the true power of Kubernetes. And underneath the Kubernetes, that's where you need a fabric which actually can let you achieve this purpose, what Datera does the best. Datera has built a very advanced storage system, but on the principle of simplicity. So a user can choose to define how exactly they want to deal with the system without worrying about the resources underneath. If you take a quick example here, so I have got a Datera system which is set up on 5 different types of servers. At Datera, we take care of multiple fabrics into a single system as is. We believe in heterogeneity. No two systems are similar. Nothing bought from one vendor is similar to another vendor. At Datera, we can incorporate resources from multiple vendors and still present them as a single fabric without user being worried about how they're going to consume it. So when you talk about multiple servers here, every server has got a different personality. I may have got some hybrid nodes which has got a media, different type of media. I have got multiple nodes which are having opt-in, NVMe, or flash. Now based on how the requirements are conveyed back from the user, we appropriately match the data to the tier. Now, what really happens with applications, so presume you have an application which actually needs more performance out of the system. User need not worry about that because when they convey the message to Datera talking about how much performance they want out of the system, Datera has written a very intelligent piece, something as a placement optimizer, which actually grabs the user's request, match it to the resources that it has awareness of, and place it appropriately onto the server, which actually match the personality of the data. If a server goes bad, it's the system resource manager's responsibility to move the data which was lying on those servers to another server. So a self-adjusting, self-efficient, self-balancing fabric right in the display. Now take it back to the promise of Kubernetes. When we talked about like Kubernetes keeps things simple, what Kubernetes does, it lets you define an application in the form of pods. A pod is nothing except a single granular piece which actually contains multiple services together. They co-host on a single server. When any of the service fails or entirely the pod fails, the entirety of the pod moves from one node to another node, keeping everything together. So when an application like MySQL runs in Kubernetes pod, it basically conveying its message of high performance resource requirement in the form of a PVC. And it basically sends the message back to Datera that it needs a storage carved out here which can provide the high performance. It could be as good as saying, okay, hey, I want 50K IOPS. When this resource is actually carved out on Datera, let's presume we carved out an app 1 with a platinum profile which actually matches the requirement that has been given here. Placement optimizer would have already taken care of making sure that these two servers are available whenever the requirement from the Kubernetes environment going to come in here. It has presented a PV back into the system, into Kubernetes. So when a PVC got created for high performance, a message is sent back to Datera Fabric, and Datera Fabric conveyed it back using the form of PV. Now once this PV is created, this is the promise of a vendor to Kubernetes that whatever you have asked for in the form of high performance, in the form of PVC, I'm going to fulfill it. So what Kubernetes does, Kubernetes actually matches this PVC to the PV. By doing that, what's happening in the underneath layer, that this pod MySQL actually have got access to the resources layer here. So if you have, let's say, ask for a SCSI block device, there's a SCSI target being created here, which is actually matching to the requirements underneath all the way, and there's a storage being presented to this pod, and that's where this whole pinning is happening. Now, if you look at the system by isolating these two worlds independent of each other, this environment can absolutely be immune to what is happening here. If a server goes down, or if another server keeps getting added here, this pod can still access the resources, because as an application developer, it's not my responsibility to worry about these resources anymore, because DoTERRA has a system built in underneath which can actually prepare your storage and keep it always up without worrying about the maintenance that is happening underneath. So if a server retires, another server comes in, but the application downtime is completely zero. This world is not at all getting affected by what's happening here. And that's a true power of a system which needs to work with a fabric like Kubernetes. At the same time, if you have another workload, which is like a Kafka, and you do not really know your performance parameters, or you do not really care about setting anything, you can just convey this requirement back to DoTERRA. And at DoTERRA, we can make the best decision based on what the requirement has come from if you do not really have everything. So we have default behaviors built into this layer all around that basically make sure that you get the best placement, best match of the resources, and giving it back to the Kubernetes fabric. Now, if you go by the argument, like, I agree that DoTERRA Placement Optimizer can make all the decisions for you. It can basically match what your application has want. How do I make a complete pinning of the resources down to the system? So if you are really sure that you want high-performance resources and you do not really know how to convey it back from your system, you can just simply put a label on your application and say, okay, hey, irrespective of my requirement, what you can read from the application, I just want gold quality of service. So when I say gold resource and then they are coming back, this gold is immediately matched to the requirement what we have set across here. And these gold parameters will make sure that the resources are carved out on the appropriate layer and they are presented back. So it means you can explicitly convey your intent, or you can let DoTERRA choose the right resources for you. It's entirely up to you. DoTERRA is built on the principles of policies and templates. So what that gives you tremendous advantage, because it lets you reuse certain definitions that you have matured, certain workloads that you have isolated and you've kept them as gold. Because further deployments want some consistency. You want to scale up your environment by introducing more applications. You can actually use the templates. So if you like something which you have already used, you can graduate that to a template. And by doing that, you're making a separate piece, something externally referenceable. Simplicity of using template can be used in a typical dynamic environment like in Kubernetes, where a stateful set, let's say, is actually dynamically introducing resources into the system and is expecting the vendor to fulfill those things at the same speed. That's where the templates are very handy. So you can have a stateful set, which is defined something like MySQL, and which is having two replicas. And it is based on a storage class, let's say MySQL. Now, a storage class has one parameter which can specify what is the template that it wants to use. Now, by conveying this template, what we are making sure, whenever this stateful set expands, introducing two different pods, pod 1, pod 2, and when the resources are introduced in the form of requirements like PVC1 and PVC2, since stateful set is using storage class, this PVC1 and PVC2 is also based on this storage class. And what would that do? That it'll send a requirement back to the DoTERRA, and DoTERRA will create two instances, which are MS1 and MS2, based on the template that it has received from the storage class. So now app MS1 and app MS2 are created, which are actually based on this template gold, and they are stitched to those PVs. And these PVs are actually mapped to these PVCs to make sure this entire system is very dynamic. Now, you want to make a small change here? Absolutely, you can go ahead and make the change. So you can just say, okay, instead of 2 replicas, you want to introduce 3, or you want to expand, you want to scale it up to 20. It'll introduce another 20 pods, 20 PVCs, and 20 PVs after getting 20 app instances created from the same template. You want to change the behavior bulk at a stateful set across all the pods from its performance or protection mechanism. You don't really need to touch these systems. You can literally go to the template, change the performance profile, or make the system more secure by introducing a snapshot schedule. This will make sure that all the changes that have been there on the template are immediately applied to the pods. Tremendous power. Not the traditional vendors can achieve it, purely because of the fact they need to create silos for doing all these things. With DoTERRA, it's still despite of having multiple different kind of servers, you can literally achieve this because Our placement engine makes sure that all the requirements that you have conveyed from the top are appropriately matched with the resources. DoTERRA and Kubernetes are from the same planet, primarily because of the fact that whatever Kubernetes does, DoTERRA extends them very easily and very organically into the system. Now we talk about the scale. Kubernetes has built-in primitives for scaling the pods in the form of stateful sets. It can scale up and scale down the applications very fast. As a result of that, it introduces dynamic resources like PVCs, PVs, and pods into the system based on the storage classes. At DoTERRA, we do the same thing by defining policies and templates. Templates make sure that all the instances created from them are looking consistent. They basically have the same type of behavior. By mapping them together, it gives a tremendous advantage for users to bring in a consistent behavior for a scaling application to the scale-out resources. Resource isolation. Kubernetes place the resources in hierarchical fashion through namespaces. So namespaces can contain pods, PVCs, and based on what user has access to, the resources get placed appropriately. DoTERRA extends the same concept and through the tenancy. In the tenancies, you can define your own pools, policies, behaviors in the form of templates. All the instances created from these templates and these policies are actually created in the tenants that you have access to. Since DoTERRA is built grounds up on the tenancy, every behavior is multi-tenancy aware. Kubernetes, for providing RBAC, it uses secrets. So secrets give you a unique way to tie your authentication credentials to the namespaces. So any user who wants to interact from Kubernetes space to the DoTERRA, we can map these secrets into DoTERRA roles. So in DoTERRA, you can define a user, something like a QA here, which has its own roles and privileges, and it has access privilege defined only for the tenant QA over here. So when Kubernetes pods are instantiated in this namespace with a Kubernetes secret defined, which can only be used by user as QA, they can only access the resource within the tenant QA. It enables administrators to have different roles and privileges defined to give the isolation of accesses and privileges across the system. Kubernetes is built for giving you the deployment velocity. It basically lets you expanding the resources at a massive speed. So you can introduce many more pods, like from here, pod 1 to pod 2, and it expects the resources to be coming in from the vendor at the same speed. At DoTERRA, we can do that because when you create the instances from the template, you are actually giving the configuration semantics right away. And underneath, we can use our clones, which are actually very thin provision volumes, to make this resource available to the Kubernetes fabric much faster than any other vendors. Other vendors may provide this by pre-provisioning certain things and making it available to the Kubernetes and giving you the impression that things are available immediately. But at DoTERRA, we make sure that resources are only provisioned at the time when the workload has a requirement. So that truly fits into the fabric what Kubernetes asks, instead of having something thick provision and making it available, wasting the resource into the land where it should not be. Simplicity. So Kubernetes keeps things simple. It abstracts out the resources. It lets you define the pods, not worrying about the applications. It lets you define the PVCs, not worrying about the resources. It lets you define the namespaces, keeping the isolation and things, everything as is. It lets you define storage classes, which basically keeps you free from defining how your storage requirement is going to be. At DoTERRA, we extend simplicity in truly amazing fashion. We rely on the principles of pools and policies, templates, tenancies, to let people think more in organic form, more humane form. People can visualize the storage as something what their application wants, instead of defining in the form of the lengths and the size and the schedules of the snapshots and other things. Tremendously, as you can see, DoTERRA and Kubernetes complement each other a lot. They are from the same planet, primarily because of the reason, because DoTERRA is not customized to Kubernetes. DoTERRA is grounds up built on the principles that Kubernetes is able to exploit now. We work great with traditional applications, and we work even better with the architectures which are built on microservices. Kubernetes and DoTERRA extend each other so seamlessly. A quick question that comes into everybody's mind: can DoTERRA actually make Kubernetes better? Yes, it can. DoTERRA is an enterprise-grade storage. It has a lot of rich features like deduplication, data protection, performance, snapshots. An app that starts with Kubernetes may not be able to use all these enterprise-grade features because Kubernetes does not expose them as first-class options. By terminating your storage onto DoTERRA, we let you handle this very well, because you can point to a DoTERRA template which actually hides all this abstraction, all this limitation underneath. And applications can move from Kubernetes environment to a non-Kubernetes environment and come back to Kubernetes without worrying about it. So one more reason to go to DoTERRA. In Kubernetes, applications are scaling faster, and along with the scale up, the data resources are getting instantiated on the storage vendors. By using Datera, you get the default data protection by placing a default snapshot policy into the same space. It's humanly impossible to back up all the resources that you are instantiating, but with the default schedules, you are guaranteed protection. Kubernetes does not let you modify the storage personality once it is defined. Once a pod has been using a PV or a PVC, you cannot really go and make drastic changes to that. But by terminating into Datera, you actually have the fundamental advantage where you can literally go to the template and modify the definition, and it automatically gets applied to all the pods. The behavior is consistent, and you can change it anytime. So you are no more bound to the restriction that a framework like Kubernetes imposes because it does not let you modify those resources. Kubernetes is built for scale. It lets applications grow super fast. A rogue application or an uncontrolled scale can leave you in a situation where you run out of resources. Your critical applications may not even get resources to run. So what should you do? At Datera, we can help you solve the problem. We can actually let you define the quota restrictions on tenants. And since we map Kubernetes namespaces into Datera tenants, we guarantee that if an application goes beyond the resources that you have set the throttling numbers on, it'll be stopped. You have a guaranteed protection against an uncontrolled scale. Another good reasons to use Datera. So if you can see, Datera is just not the fit for Kubernetes, but actually it makes Kubernetes even better. It lets you adopt Kubernetes without worrying about what would happen in an environment. A typical multi-user, multi-tenant, and extremely scaled out environment in Kubernetes, Datera should be a natural choice. Why? Because Datera is not customized for Kubernetes. This is how Datera is built, what Kubernetes can take advantage of. Thank you.
Learn more about how Datera brings the software-defined revolution to enterprise storage at datera.io and contact Datera for a free consultation.